Hi everyone, my name is Dipesh Kataria and my project topic is image classifier, or we can call it a sign or number classifier or recognizer. The scope of this project is it takes an image and classify into categorical list. We can use this project in various fields. We can use this project with the people with disabilities and their relatives. Those who can't understand the sign language, for them it will take the image of the sign and it will convert into the text. Or we can train other things too. Like we can train an empty room as an image in the model, and one image with some persons in the room, and classify the images like empty room or someone is in the room. It is an anti-theft application. The project is divided into three parts. First part is data generation, second part is modeling, and third part is predictions. In first part, what we do is we get the hand histogram, where white pixels have like white color has like more pixels, and other colors have like less pixels. So we train this model over your skin tone. So for the first part, there's a file named set hand hist. We run that file, and in the first function we create these 50 boxes, square boxes that you can see on your webcam. And when you place your hand on all of the squares and press C, you can see a binary. Wait a second. Okay, yeah, now it's working. Yep. Now it's just place your hand over there and press S when you are satisfied with the grayscale image. Yep. And the second part of data generation, there is gesture feeding. So you have to enter the gesture number, like enter 6, and type the name of the gesture 6. Once we run the file for data generation, we can see a webcam feed in front of us, and there's a a grayscale image out of for our region of interest. So when we place our hand when we are ready with the gesture, we can just place our hand there and press C. So it will take some time to start recording the gestures. Yeah, now. Yeah, it takes some time. Like when you press C two times, it pauses the capturing feed, and you have to press C again to resume the capturing. Yeah. You just have to move your hand in the front of webcam to capture the images. The counter will reach 400, and it will stop automatically when we have stored like 400 images. Yep, you're almost done there. When we have stored all our gestures, we can continue with the project. The next step is modeling. Let me just get to the modeling. Well, so sorry for the webcam feed, because I can't use my webcam for recording, and I can't use for the project at the same time. So I have to like use the webcam in the project itself. Okay, let's move to the training part. I have used Keras to implement convolutional neural networks. So in this one, like we have trained CNN over the images that we have fed. So I have created like 0, 1, 2, 3, 4, 5 numbers and saved the 400 images for them. Let's go with the modeling thing, and as we can see here, I have imported the Keras modules, And this is our first convolutional layer where our input shape is 50/50, that is pixels of the ROI that we have. You can change it to whatever you want. And this one here, this one is for the grayscale, and if you are using a RGB image, we can change it to 3 and we can use a RGB image here. And activation is a activation function that we use to separate the values of x. ReLU is an activation function, or rectifier linear unit, which provides a 0 for the x values uh, less than 0, and x for the values more than 0. And this is our second convolution layer, where we have transferred the input from the first convolution layer. Then we have flattened the convolutional layers into a array, and use the softmax function, because it takes a probability distribution for k classes. And for optimizers, we have used Adam. Adam is nothing, just a advanced version of adaptive gradient boosting. And we have used categorical cross entropy, because we can't use here cost function, because cost functions become cross entropy when the class is being raised from more than 2, or we are using more hidden layers. After this, we have used image processing and fed our images into the model and trained that for 10 epochs. The model is quite computationally expensive, and it takes like 4 to 5 hours to run if you have only a GPU machine. It will be really less time if you have a if you have a GPU, it will be less time, and if you have a CPU, it will take like 3 to 4 hours. So I'm not going to run our model right now. I have already run it in the night, and it takes like 4 to 5 hours to save the model into a JSON file. And in predictions, we are going to get that model, and using OpenCV will capture the live feed here. Yeah. So we are using OpenCV to capture the live feed, and using that model to do the predictions here. As you can see, I have defined the category dictionary here: 0 for 0, 1 for 1, 2 for 2. So let's start doing some predictions here. So that's for 0. You just have to manage your hand because of the background. And let's see, that's 5 for 2. Yep, 2, and 4, 3, and 4, 1. Yeah. As it is a computationally expensive model, we can use teachable machines to do better predictions, and train RGB images and use that model in our predictions. So let's see what we can do. So yeah, for this, you just have to define the classes. We can't record it here, so because of the we are using the webcam for recording. I'll just make another video to showing that. As you can see here, I have just uploaded some samples images using touching my face, and one is without touching my face. So here we can change the parameters, how many epochs we want to train it, and what will be the batch size for each step, and what is the learning rate. In our project, I have used Adam optimizer, adaptive gradient boosting for advanced learning rate. And here, but we have to define the learning rate, so we should be keeping in mind that the learning rate should be less, otherwise we'll move over the optimal point. As you can see, this model has like better accuracy than ours because it is trained on the RGB. And we can use this model and export it in Keras, and we can just directly use import this model into our predictions and use these categories to classify our images. We can use that model and import into our predictions and define the categories and labels for those predictions. And but we have to change the image size here and the parameters for changing from our grayscale to RGB. In by doing that, our project have like a lot of scope, and we don't have to compromise our computational power. As when I started working on this project, I have wasted a lot of time in computation because my laptop doesn't have any GPU. I was only working on the CPU, so it took like 4 to 5 hours to run a model one time, and it showed an error. So I have tried to find another solution. I have looked for teachable machines, but where we can train our model, and we can extract that model and do the predictions right away. And for the conclusion, we can use this model in a lot of places. We can use it for anti-theft cameras, and we can use it to predict the text for the sign languages in like courtrooms, or in people having someone interactions with disabled people. So yeah, there's a lot of scope for this project, and there are a lot of products in the market that are using the same kind of technology to predict the sign languages. For further, we can connect this project to Alexa and deploy it, or Alexa, so Alexa can convert the images into images into speech. That's it. Thank you.